we will go through the Python code for support vector machine today. But before that, let's have a very small recap what exactly support vector machine was. Like support vector machine is a machine learning algorithm which basically not only makes a decision boundary, it also guarantees that the the vector or the point of each class, if I consider only two class, point of two classes will be as far apart as possible. That means, and those points in the classes are called support vectors, right? So in this diagram, as you can see, this is one support vector in this side and this is another support vector in this side. But remember, it is not a or it is not always true that you will have only one support vector in a decision margin. I'm sorry, not yeah, decision margin. You may have multiple support vectors in the decision margin line in both sides, or maybe one. But the prime motivation for a support vector machine algorithm is to make this decision margin as wide as possible, and that was our task, right? So we actually tried to maximize this value of d in some way, and we got a maximization function something like this. And as we all know that it's always we try to minimize something, so maximizing 2 by w norm, it's nothing but actually minimizing just opposite one. I mean w norm by 2, something like that, right? So let's go to the next one. So we have maximizing this one. So what basically we'll try to do, we'll try to do this minimize of w norm by 2. And what is this w norm? W norm is that particular vector which is perpendicular to this decision margin or decision boundary. And also you have seen there are two more parameters coming here in the right hand side, that is c and omega. I'm sorry, c and lambda, sorry, gamma. What is this c? C is basically we call a regularization parameter, and gamma is some error magnitude. You remember this c and gamma here for a moment, because when we will write code, I will show you, you will see that there will be an option to put different value of c and gamma as per your wish. So we will see that. And one more thing we have seen, that there is a possibility always that the data set is not linear. In that case, what we have to do, we have to do some transformation to make the data linear so that we can apply some support vector machine algorithm. That's why different type of transformation possible. So here I have shown you two different transformation, from here to here and from here to here, so that we can put a boundary in between them. And so based on different function we can do this transformation, and these are the different kernel function we have by which you can do this transformation. Already we have seen that. So I'm not going in much detail of support vector machine theory. So let's go to the code and let's see how support vector machine is basically creating the classification boundary, and try to visualize that. Okay. The code that you can see here in a Python notebook is a very basic code of support vector machine. I will explain a bit so that you can understand and visualize it properly. So the first thing that you can see here in the first cell, we have just initialized some, we have imported some packages which will be required for, doing the computation. And let's come to the second cell. Here, a very interesting thing, and you can see that there is a function, you see, make blobs, right? So this make blobs is a function which basically comes from scikit-learn.dataset, as you can see here. Let make it little bigger for you. This make blobs function actually can helps you to create some synthetic data. Synthetic data means some arbitrary data set which does not have any connection with real life example. What you can do, you can use that particular data set for doing some practice on some model design or something like that. So it is nothing but creating a data in some particular distribution, and that's why you see the standard deviation has been given here, say 0.60. So the data that we will get, total number of data we will get 50, which will be have some two different clusters, and there will be some standard deviation between the clusters as 0.60. And then just we have, you know, tried to visualize that data set by a scatter plot here. So if I just run this code, you will see, okay, sorry, it has not been, so I have to execute this one, then I have to execute this one. Yes. So I think you can see here that it's basically given two set of data here in two different color, easily you can see, and visually it is very easy to understand. It is not, it's a very simple linear classification possible here. I can simply draw a straight line in between this two data set. So if you try to apply support vector machine algorithm to find the decision boundary which can classify this data set in 100% accuracy, the thing that you have to do, we can easily use simply linear kernel. Linear kernel means basically there is a linear transformation, means there will be no changes from the data set that presently we have and the data set on which the support vector machine will work on. So that's why you see here, for calling or for executing the support vector machine algorithm, again you have to use some package from scikit-learn. You can see here it's given from sklearn.svm. svm means stands for support vector machine. Import svc, because we are actually going for a classification task. That's why support vector for classification. If we go for a regression type of task using the same algorithm, support vector machine, that is also possible. In that case, instead of svc, it will be svr. Okay. Anyway, if we try to do some regression model using some another dataset with support vector machine, there I will show you that how we can use svr instead of svc and do our computation. Anyway, so this svc will be required for us to create the model. And as you can see here, it is given here model equal to svc because it's creating the model with, here I have mentioned kernel equal to linear. And you see c equal to 1. What is c? This is the c that already you have seen just few minutes back in the presentation. That is the regularization parameter. Now you know there are different other parameters possible you can put in this svc function. So if you just for your own interest or maybe for designing some complex model, you have to put those parameters here as well. Or maybe you can do some research, do some trial and error technique to check which particular parameter values will be best for your dataset. To do this, first you have to understand what this svc is. So I'll show you here. You can see another tab here which is written as sklearn.svm.svc. You can easily search it in Google. You will find this page which is from scikit-learn package, scikit-learn.org. Here you can see lot of parameters you can have in this svc function. For example, I have used c, right? Since for each and every parameters there are some parameters which is by default. Okay, if you don't apply that parameter, don't specify that parameter by some specific value, there will be some default value taken. For example, I have written c equal to 1 in my code, but if I don't write c equal to 1, then also by default c value of c will be equal to 1, as you can see here. Similarly, for kernel also, by default the kernel is RBF, which is called radial basis function kernel. What is radial basis function? We have not yet explored. We will see that later. Similarly, there is another function for degree, another gamma, and this gamma also I think you can remember. Just you have seen few minutes back in slide. That is nothing but representing the error. So you have two different form of gamma, either scale or auto, where default is scale. And if the value of gamma is scale, then how the, then what I mean, then it will basically use 1 by number of features into x dot variation, where all these details is given here. So if you want to check what are the different parameters you can pass and what are the different values you can pass in the parameters, you can easily check this website and you can accordingly you can design your own model. So now let's go back to the code again. So you see here, so what it is doing, it is basically creating a model of support vector machine of classification model, and then I'm simply doing model.fit. This type of fit function you have already seen in previous machine learning models as well, right? So it's not very new to you, I hope. Anyway, let's run this code. So running this code completes. Running this code completes means learning of the model is completed. Now what I can try to check how the decision boundary has been created. To do this, here we have a function. This particular function is basically creating that decision boundary, including the margins. Okay, so I'm not going in much detail of exactly what is written in this function. Just one thing I can show you, I can tell you that you see this ax is nothing but basically creating some axis, and based on this we have a function contour of this axis, and this contour function is actually creating, mostly responsible for creating the decision boundary and the margin. Anyway, you can go in detail to each and every line to check what's happening by by printing the output. Anyway, I'm just, for time being, I'm just executing this particular function. So this function done, and now I'll come back here, where first I have created the scatter plot again, and then I have called this plot svc decision function, that is this one. So what basically it will do, over this scatter plot, what already we have seen, something like this, it will show that decision boundary and including the margins. So if you just run this particular cell, you will see this is the decision, the different data set already we had, and this is the decision boundary including the support vector margins has been created. Okay, so I hope now the the technique is clear to you, that what exactly support vector machine is doing. So when a new point will come, okay, that new point will be decided based on this decision boundary, in which side it has, is it this side or that side, and based on that the classes will be decided, as simple as that. Anyway, But if you try to check the importance of, say, for different parameters, including that value of c, that is a regularization parameter. So what one thing we can do here, let's take a almost linearly separable data set. I'm saying almost means there will be very small difference between that. You see, that's why we have you know the standard deviation has become increased, so scatteredness will increase. If you print this, you will see that the two data set has been merged almost. There is very, it's almost difficult to find a particular straight line in between these two data set, right? Anyway, but still we will try to manage this. And you see here what I have done. I have created a data set like this using make blobs, as simple as that. And then first we have presented in a plot. So let's do one thing. Let's run this particular part. So we have only this blocks is created, which blocks, where we will have the different data, classes of data. But what actually I have done here, not I have done actually, by the way, I must say that I have not written this code by myself. I've taken this code from a particular link, which is this particular GitHub link. So this particular GitHub link has this data, this particular file. So we can easily check at any point of time. I'm just explaining it. So I found that this particular link is very good for understanding. That's why I'm showing you. Anyway, so let's go back to the code. So what I've done here, you see, I've written a for loop. And what I'm doing, I'm basically iterating the for loop over this axis on different value of c. In one case, I have taken value of c as 100, and in one case, I have taken value of c as 0.01. And if it is, and based on that, I am fitting the model. And then I am checking how the decision boundary function, decision boundary and decision margin will be created on the dataset. Here also I have taken linear kernel, so there is no changes in the original data. So if you run this, you will see that. Just a minute. What happened? Just a minute. Yes, it is now came. Yes, true. So you see here, initially when value of c was 100, so regularization parameter was 100, the decision function is so close to each other. And if it is 0.0, when c is basically, value of c is basically 0.0, 0, it's basically doing what? It's basically, the decision function is created so huge. So there is a lot of data which is present after this decision merging in both sides, which is not good. So from this example, I think it's clear. One thing is clear, that how important the value of c is to make the best classification score using support vector machine.